Hello everyone, welcome to chemistry classes. In the previous class we have discussed about molar conductivity. So what do you mean by molar conductivity? The conductivity of 1 mole of electrolyte is called as molar conductivity. So now we'll discuss something more about that. So now the next term is limiting molar conductivity. My next term is limiting molar conductivity. Limiting molar conductivity. So it is symbolized by lambda naught m. The lambda naught m, it is the same, lambda naught m. In some text they have given the symbol like this or like this. Both are same. There will be no difference between them. Okay, so next we'll study about this thing, the limiting molar conductivity. So here the molar conductivity of a electrolytic solution, the molar conductivity of a electrolytic solution when the concentration approaches zero. The concentration of the electrolyte approaches zero, or it is also known as infinite dilution. Infinite dilution is called as limiting molar conductivity. That is called as limiting molar conductivity or molar conductivity at infinite dilution. So it is just, what do you mean by molar conductivity? Molar conductivity is the conductivity of 1 mole of electrolyte. So to that electrolytic solution I will keep on adding solvent. On adding solvent, what happens? The concentration of solute decreases. So the concentration of solute decreases when the concentration of solute approaches zero. The concentration goes on decreasing on adding some more amount of solvent. When the concentration approaches zero, at that point we can also call it as infinite dilution. The dilution is maximum, infinite. So at that condition, the conductance of that electrolytic solution is called as limiting molar conductivity or molar conductivity at infinite dilution. So now the electrolytic solution ತಗೋತೀವಿ. Suppose ಆ electrolytic solution ಒಳಗೆ 1 mole electrolyte ಇತ್ತು ಅಂತಂದ್ರೆ ಅದರ ಕಂಡಕ್ಟಿವಿಟಿ ಏನು ಕರಿತೀವಿ ನಾವು? ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಕರೀತೀವಿ ಅಥವಾ ಮೋಲಾರ್ ಕಂಡಕ್ಟನ್ಸ್. ಸೊ ಇವತ್ತು ಏನು ಡಿಸ್ಕಸ್ ಮಾಡೋದು ಅಂತಂದ್ರೆ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆರ್ ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟನ್ಸ್. ಇದರ ಸಿಂಬಲ್ ಏನು? ಲ್ಯಾಂಬ್ಡಾ ಎಂ ಅಂದ್ರೆ ಮೋಲಾರ್ ಕಂಡಕ್ಟನ್ಸ್, ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಂ ಅಂದ್ರೆ ಏನು? ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟನ್ಸ್. ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಂ ಓನ್ಲಿ. ಸೊ ಹಿಂಗಂದ್ರೆ ಏನಂತಂದ್ರೆ ನಾನು 1 ಮೋಲ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅನ್ನು ತಗೊಂಡಿರ್ತೀನಿ, ಹೌದಾ? ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ನಾನು ವಾಟರ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ನಾನು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಐ ಟೇಕ್ 1 mole ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ dissolved in 100 ml of water. 100 ml ವಾಟರ್ ಅಲ್ಲಿ 1 mole ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಏನು ಮಾಡ್ತೀನಿ ನಾನು? ಡಿಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ಸೊ ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ನಾನು ವಾಟರ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ವಾಟರ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ? ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಗೋಸ್ ಆನ್ ಡಿಕ್ರೀಸಿಂಗ್. ಇದರ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಏನಾಗುತ್ತೆ? ನಮಗೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಹೌದಾ? ಸೊ ಯಾವಾಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜೀರೋ ಆಗುತ್ತಲ್ಲ, ಯಾವಾಗ ನಮ್ದು ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಥವಾ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜೀರೋ ಆಗುತ್ತಲ್ಲ, ಆ ಕಂಡೀಷನ್ ಏನ್ ಹೇಳ್ಬೋದು ನಾವು? ಮ್ಯಾಕ್ಸಿಮಮ್ ಡೈಲ್ಯೂಷನ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ಬೋದಾ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಮೀನ್ಸ್ ವಾಟ್? ಇನ್ಫೈನೈಟ್ ಡೈಲ್ಯೂಷನ್. ಅಟ್ ದಟ್ ಕಂಡೀಷನ್, ಆ ಕಂಡೀಷನ್ ಅಲ್ಲಿ ಸಪೋಸ್ ಆ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಕಂಡಕ್ಟಿವಿಟಿ ಚೆಕ್ ಮಾಡಿದೀವಿ ಅಂತಂದ್ರೆ ಆ ಕಂಡಕ್ಟಿವಿಟಿಗೆ ಏನ್ ಕರಿಬೇಕು ನಾವು? ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಅಂತ ಕರಿಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ ಇದು? ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ. ಸೊ the limiting molar conductivity is different for strong electrolyte and weak electrolyte. And also we know that there are two type of electrolytes. The first one is called as strong electrolyte, the another one is called as weak electrolyte. So the limiting molar conductivity is different for strong electrolyte as well as for weak electrolyte. It is not same for both the type of electrolytes. And also we should know about what is strong electrolyte and what is weak electrolyte. So what do you mean by strong electrolyte? If an electrolyte is dissolved in water, what should it give? If the electrolyte is completely dissociated in water, so that is called as strong electrolyte. If it is not completely dissociated, then that is called as weak electrolyte, isn't it? So because of difference in their dissociation capacity or dissociation quality, they are divided as strong electrolyte and weak electrolyte. For strong electrolyte, the lambda naught m value is different. For weak electrolyte, the lambda naught value is different. So let us discuss how the lambda naught value changes with in case of strong electrolyte and in case of weak electrolyte. Okay, so the variation of molar conductivity with concentration. This molar conductivity is nothing but which conductivity it is? This is nothing but limiting molar conductivity. Variation of molar conductivity with concentration. So let us take first case, which is first case for strong electrolyte. For strong electrolyte, so on changing the concentration, how the conductivity of strong electrolyte changes? For strong electrolyte, molar conductivity approaches certain limiting value. For strong electrolyte, the molar conductivity approaches certain limiting value when the concentration approaches 0. So if I take strong electrolyte on dilution, so keep on if I keep on diluting that electrolytic solution, the concentration of electrolytic solution reaches certain the concentration reaches 0. So at that point, the strong electrolyte conductivity of strong electrolyte has got some certain limiting value. So the limiting value of the strong electrolyte at infinite dilution is given by an equation known as Debye-Huckel-Ohlsager equation. Debye-Huckel-Ohlsager equation. So for which purpose we use this Debye-Huckel-Ohlsager equation? By using Debye-Huckel equation, it gives the variation of molar conductivity with concentration for strong electrolytes. So ಇದು Debye-Huckel-Ohlsager equation ಯಾರಿಗೆ ಯೂಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ, ನಾವು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಯಾವ ತರ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಯಾವ ಕೇಸಲ್ಲಿ ಇದು? ಇನ್ ಕೇಸ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಸೊ Debye-Huckel-Ohlsager equation is particularly used for strong electrolytes. Please remember, we cannot use Debye-Huckel-Ohlsager equation for weak electrolytes, isn't it? So this is only for strong electrolyte. According to Debye-Huckel-Ohlsager equation, so it has given, there is a formula. So what's that? Lambda m is equals to lambda naught m minus a into c raised to 1 by 2. So we know all the terms, almost all the terms we know except one. So lambda m is what? Molar conductivity. Lambda m, we know that, molar conductivity. Lambda naught m means what? Limiting molar conductivity. Where lambda naught m is limiting molar conductivity, and where a is called as, a is a constant, where a is a constant, and c is concentration. C means what? Concentration. Raised to 1 by 2 means what? Root. Anything raised to 1 by 2 means what? A raised to 1 by 2, sorry, c raised to 1 by 2 is equals to root c, isn't it? So lambda m is equals to lambda naught m minus a into c raised to 1 by 2 or root c, where a is constant, c is concentration, lambda naught m is the limiting molar conductivity, and lambda m is the molar conductivity. And the value of a depends upon at a particular temperature and for a given solvent. At a particular temperature or for a given temperature in a given solvent, the value of a depends upon the electrolyte. It depends upon type of electrolyte. So the electrolytes are divided on the basis of so many criteria. You can divide them in many ways. Here the A is the type of electrolyte. Here the electrolytes are divided or classified on the basis of number of cations and number of the charges on cation and number of charges on anion. Here for this purpose A is constant. The value of A depends upon the type of electrolyte. The type of electrolyte means what? Here the electrolytes are divided as the number of charges on cation and number of charges on anion. Based on this criteria, we can divide the electrolytes. So if I take NaCl, NaCl is an electrolyte. If I dissociate NaCl, what I am going to get? If NaCl is dissolved in water, what I am going to get? NaCl gives Na plus and Cl minus. Here the number of charge on cation is 1 and number of charge on anion is also 1. So therefore this electrolyte is of the type 1,1 type electrolyte. This electrolyte is called as 1,1 type electrolyte. If I take another electrolyte, MgCl2. So now what I can write? Mg2 plus 2 into Cl minus. Mg2 plus 2 into Cl minus. So what is the charge on cation? 2. What is the charge on anion? 1. So this is 2,1 electrolyte. MgCl2 is the type of electrolyte. Which type of electrolyte? 2,1 type of electrolyte, isn't it? So here the type of electrolyte is classified. Electrolytes are classified on the basis of number of charges on cation and number of charges on anion. So I will give the one more electrolyte. So if I take AlCl3, which type of electrolyte it may be? Which type of electrolyte? Here on dissociation, on dissociation, what it will give? Al3 plus 3 Cl minus. So what is the charge on cation? 3. What is the charge on anion? 1. Actually it is minus 1, it is plus 3. So we can generally take 3,1 type electrolyte. So it is 3,1 type electrolyte. So please remember here NaCl is 1,1 type electrolyte. CSCl, cesium chloride. So on dissociation, what will give? Cs plus Cl minus. So cesium chloride is also 1,1 type electrolyte because the number of charges of cation is 1, the number of charges on anion is also 1. So it is also 1,1 type electrolyte. 1,1 type electrolyte. Here MgCl2 is 2,1 type electrolyte. MgSO4. Here comes MgSO4. MgSO4. On dissociation, what are you going to get? Mg2 plus SO4 2 minus. So which type of electrolyte it is? Yes, it is 2,2 type electrolyte. It is 2,2 type electrolyte. So the value of A depends upon this. And please remember one more thing. The value of A remains same for particular type of electrolyte. Here the value of A is same for NaCl and CSCl because NaCl is also 1,1 type electrolyte, CSCl is also 1,1 type electrolyte. So the value of A is same for particular type of electrolyte. Okay. So next, now let's move forward. Here, this Debye-Hückel-Ohlmsager equation can be written like this. Lambda m is equals to, this term is written here and this term is written here. Just they are interchanged. The position of them are interchanged. Lambda m is equals to minus a root c. In the place of c raised to 1 by 2, I have written root c plus lambda naught m. So this equation looks like, or it is of the form y is equals to mx plus c, isn't it? So this equation looks like that. Y is equals to mx plus c, where y is equals to what? Lambda m, x is equals to root c. If I plot a graph y versus x, if I plot a graph y versus y, lambda m along y axis and root c along x axis, what I am going to get? I should get a straight line because this is the equation of straight line. I must get a equation of I must get a straight line with intercept c is equals to lambda m, and what is m? M is slope. The slope will be minus a. So slope minus indicates what? The curve is negative curve. The curve is negative curve. So here the lambda m versus root c. Lambda m versus root c, lambda m along y axis, root c along x axis. See here, on going from this 0 to x, on going along x axis, concentration goes on increasing. Concentration goes on increasing. So if we come towards the origin, the concentration goes on decreasing. And please remember, so this is lambda m. What happens? What we have studied? For strong electrolyte, molar conductivity approaches certain limiting value when concentration approaches 0. So based on this, we have drawn the graph. It's a experimental data graph. What happens here? Here, the concentration of electrolyte is high. When the concentration of electrolyte is high, the value of the curve is very low. The lambda m value is very low. As concentration decreases, when concentration decreases? On dilution. On diluting, what happens? Concentration decreases. Concentration ಯಾವಾಗ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ ನಮಗೆ ಡೈಲ್ಯೂಷನ್ ಮಾಡಿದಾಗ ನಮಗೆ ಏನು ಗೊತ್ತು ಡೈಲ್ಯೂಷನ್ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಹೋದಂಗೆ ಏನಾಗುತ್ತೆ ನಮಗೆ ಲ್ಯಾಂಬ್ಡಾ m ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಸೊ ನಾವು ಈ ಕಡೆ ಬರ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಇದರ ಮೀನಿಂಗ್ ಏನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಅಂದಂಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಮಾಡೋದಂದ್ರೆ ಏನು ಡೈಲ್ಯೂಷನ್ ಜಾಸ್ತಿ ಮಾಡೋದು ಅಂತ ಅಂದಂಗ ಸೊ ಡೈಲ್ಯೂಷನ್ ಮಾಡಿದಂಗೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ as the dilution increases the lambda m value goes on increasing lambda m value goes on increasing so lambda m value increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಹೌದಾ so we have drawn graph up to these values of concentration from this to this only now what we have to study we want the molar conductance at infinite dilution means what at zero concentration at this point what is the value of lambda m so this can be given directly as on extrapolating this curve ee curve ಏನು ಮಾಡೋಣ extra ಬೆಳೆಸೋಣ ಸ್ವಲ್ಪ so what we are going to get on extrapolating this curve yes this curve will cut y axis at this point is known as lambda naught m ಈ ಪಾಯಿಂಟ್ ಏನಿರುತ್ತೆ ವ್ಯಾಲ್ಯೂ lambda naught m that lambda naught m is nothing but limiting molar conductivity so lambda naught m ಅಂದ್ರೆ ಏನು limiting molar conductivity so limiting molar conductivity for strong electrolyte can be given graphically like this okay so here the slope is equals to what was the slope is equals to minus a for this the slope is equals to minus a so like this for strong electrolyte limiting molar conductivity can be calculated so this is about strong electrolytes next go towards weak electrolytes now we'll study about weak electrolytes so what happens when the concentration approaches zero or on dilution increases up to infinite so what is the change here the variation of molar conductivity with concentration for weak electrolytes now we have to study for weak electrolytes like acetic acid for a weak electrolyte means what electrolyte which is partially dissociated incompletely dissociated in the aqueous solution it is called as weak electrolyte the weak electrolyte like acetic acid for weak electrolyte like acetic acid they have low degree of dissociation means what the degree of dissociation is given by alpha means what we have learned about this in the topic called as equilibrium do you remember so degree of dissociation means what the fraction of molecules which are undergone dissociation in the water or in aqueous solution so degree of dissociation is very much less for acetic acid because acetic acid is a weak electrolyte okay so at the concentration at higher concentration degree of dissociation is very less lambda m molar conductivity of such electrolytes increases with dilution see here if I take 100 ml of water I will add 1 ml of acetic acid so degree of dissociation is very less if I add 100 molecules of acetic acid only 10 molecules are dissociated in 100 ml now I will add 100 more ml of water what will happen 10 more molecules of acetic acids are dissociated so now the total volume is 200 ml and how many molecules are dissociated in 100 ml, sorry, in our 100 molecules, among our 100 molecules 20 molecules are dissociated now. So if I add 100 ml more, then what happens? The total volume becomes 300 ml. At that 300 ml, the 30 molecules are dissociated, isn't it? So 10 molecules for 100 ml and 10 more molecules for one more 100 ml. Like that, if I keep on adding more and more and more amount of water, what should happen? Ultimately, all the molecules of acetic acid are dissociated. At that condition, alpha is equals to what? Alpha is equals to 1. Means the weak electrolyte is completely dissociated at infinite dilution, isn't it? So that is the point. It is the molar conductance of such electrolytes, such means what? Weak electrolytes increases with dilution due to increase in the alpha. Increase in alpha means what? Increase in the degree of dissociation. On dilution, degree of dissociation increases. As a result, lambda m increases. Totally. Weak electrolyte, for example, ಯಾವ ತಗೊಂಡಿದ್ದೀವಿ ನಾವು ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಅನ್ನು ತಗೊಂಡಿವಿ. ನಾನು 100 ml ವಾಟರ್ ನಲ್ಲಿ 1 ml ಏನು ಮಾಡ್ತೀನಿ, ನಾನು ಅಸಿಟಿಕ್ ಆಸಿಡ್ ನ ಆಡ್ ಮಾಡ್ತೀನಿ. ಆಕ್ಚುಲಿ 1 ml ಅಲ್ಲಿ ಬಹಳಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ ಇರ್ತವೆ, ಬಟ್ ನಾನು ಏನು ಕನ್ಸಿಡರ್ ಮಾಡುತ್ತೀನಿ ಅಂತಂದ್ರೆ, ಈಗ ನಾ ಆಡ್ ಮಾಡಿದಂತ ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ಓನ್ಲಿ 100 ಮಾಲಿಕ್ಯೂಲ್ ಮಾತ್ರ ಇದ್ದಾವೆ. ಎಷ್ಟಿದ್ದಾವೆ? 100 ಮಾಲಿಕ್ಯೂಲ್. ಸೊ 100 ml ವಾಟರ್ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು, 100 ಮಾಲಿಕ್ಯೂಲ್ಗಳನ್ನ ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಗಳನ್ನ ಆಡ್ ಮಾಡಿದ್ದೀನಿ. 100 ಮಾಲಿಕ್ಯೂಲ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್. ಸೊ ಇದರಲ್ಲಿ ಏನಾಗುತ್ತಂದ್ರೆ, ಈ ಆಡ್ ಮಾಡಿದಂತ 100 ಮಾಲಿಕ್ಯೂಲ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಅಲ್ಲಿ ಓನ್ಲಿ 10 ಮಾಲಿಕ್ಯೂಲ್ ಮಾತ್ರ ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ತವೆ. ಓನ್ಲಿ 10 ಮಾಲಿಕ್ಯೂಲ್ಗಳು ಮಾತ್ರ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿರ್ತವೆ. ಅಂಡ್ ದ 90 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್ ರಿಮೇನ್ ಅನ್ಡಿಸೋಸಿಯೇಟೆಡ್. ಓಕೆ. ಸೊ ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ನಾನು ಮತ್ತಷ್ಟು ಇನ್ನೊಂದು 100 ml ವಾಟರ್ ನ ಆಡ್ ಮಾಡ್ತೀನಿ. ಫಸ್ಟ್ ಎಷ್ಟಿತ್ತು? 100 ml. ಮತ್ತೆ 100 ml ಆಡ್ ಮಾಡ್ತೀನಿ. ಸೊ ಟೋಟಲ್ ವಾಲ್ಯೂಮ್ ಎಷ್ಟಾಯ್ತು ನಮ್ದು? 200 ml. ಹೌದಾ? ಸೊ ಹಂಗಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಈಗ 100 ml ವಾಟರ್ ನಲ್ಲಿ 10 ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿದ್ದು, ಇನ್ನ ಎಕ್ಸ್ಟ್ರಾ 100 ml ಆಡ್ ಮಾಡಿದೀನಿ. ಸೊ ಆಡ್ ಮಾಡಿದಂತ ಎಕ್ಸ್ಟ್ರಾ 100 ml ಒಳಗೆ ಮತ್ತೇನಾಗ್ತವೆ ಅಂದ್ರೆ, ನಮ್ಗೆ 10 ಎಕ್ಸ್ಟ್ರಾ ಅಸಿಟಿಕ್ ಆಸಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಗಳು ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ತವೆ. ಟೋಟಲ್ ವಾಲ್ಯೂಮ್ ಎಷ್ಟಾಯ್ತು ಈಗ? 200 ml. ಟೋಟಲ್ ಎಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ ಡಿಸೋಸಿಯೇಟ್ ಆದ್ದು? 20 ಮಾಲಿಕ್ಯೂಲ್. ಹೌದಾ? ಮತ್ತೆ 100 ml ಆಡ್ ಮಾಡಿದ್ರೆ ಮತ್ತೆ 10 ಮಾಲಿಕ್ಯೂಲ್ ಅಂತ ನಮಗೆ ಡಿಸೋಸಿಯೇಟ್ ಆಗ್ತವೆ. ಸೊ ಆ ತರ ನಾನು ಇನ್ನೂ ಜಾಸ್ತಿ ನೀರನ್ನ ಆಡ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ, ಬಹಳಷ್ಟು ನೀರನ್ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ ನನಗೆ? ದ ಡೈಲ್ಯೂಷನ್ ಬಿಕಮ್ಸ್ ಇನ್ಫೈನೈಟ್. ಅಟ್ ದಟ್ ಕಂಡೀಷನ್ ಆಲ್ 100 ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್ಸ್ ಆರ್ ಡಿಸೋಸಿಯೇಟೆಡ್. ಅಲ್ಲಿರುವಂತ 100 ಮಾಲಿಕ್ಯೂಲ್ ಅಸಿಟಿಕ್ ಆಸಿಡ್ಗಳು ಏನಾದ್ರು ನಮ್ಗೆ ಡಿಸೋಸಿಯೇಟ್ ಆಗಿಬಿಟ್ಟು, ಈ ಕಂಡೀಷನ್ ಏನ್ ಹೇಳ್ಬೋದು ನಾವು? ನಾವು ಅವರ್ ಅಲ್ಫಾ ಬಿಕಮ್ಸ್ ಈಕ್ವಲ್ ಟು 1. ಅಲ್ಫಾ ಏನಾಯ್ತು ನಮ್ಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಯ್ತಾ? ಸೊ ಎಲ್ಲ ಮಾಲಿಕ್ಯೂಲ್ ಡಿಸೋಸಿಯೇಟ್ ಆದವು ಅಂತಂದ್ರೆ ಅಲ್ಫಾ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಏನಾಗುತ್ತೆ? 1 ಆಗುತ್ತೆ. ಸೊ ಆಸ್ ಅಲ್ಫಾ ಬಿಕಮ್ಸ್ ಈಕ್ವಲ್ ಟು 1, ದ ನಂಬರ್ ಆಫ್ ಅಯಾನ್ಸ್ ಆರ್ ಗ್ರೇಟರ್. ನಂಬರ್ ಆಫ್ ಅಯಾನ್ ಜಾಸ್ತಿ ಇದ್ವು. ಸೊ ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಮಗೆ ದ ಲ್ಯಾಂಬ್ಡಾ ಎಂ ವ್ಯಾಲ್ಯೂ ಇನ್ಕ್ರೀಸಸ್. ದ ಲ್ಯಾಂಬ್ಡಾ ಎಂ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಬಟ್ ಇಲ್ಲಿ ಸಪೋಸ್ ನಾವು ಇದನ್ನ ಏನ್ರೆ ಗ್ರಾಫಿಕಲಿ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಕ್ ಹೋದ್ವಿ ಅಂತಂದ್ರೆ, ಇಫ್ ಐ ಟ್ರೈ ಟು ರೀಪ್ರೆಸೆಂಟ್ ದಿಸ್ ಥಿಂಗ್ ಇನ್ ಗ್ರಾಫಿಕಲಿ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಕ್ ಟ್ರೈ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ, ವಾಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಈಸ್, so I will draw the graph here. So this is the concentration, this is lambda m, this is my y axis, this is my x axis. So this is concentration 0. Suppose ನಾನು ಏನ್ರಿ ಇದಕ್ಕೆ ನಾನು ಗ್ರಾಫಿಕಲಿ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಕ್ ಹೋದ್ನಿ ಅಂತಂದ್ರೆ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? at concentration approaches 0, the graph increases steeply. ಗ್ರಾಫ್ ಏನಾಗುತ್ತೆ ನಮಗೆ? ಸ್ಟೀಪ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಸೊ ದ ಗ್ರಾಫ್ ಬಿಕಮ್ಸ್ ಲೈಕ್ ದಿಸ್. ಸೊ ದಿಸ್ ಈಸ್ ಫಾರ್, here this graph is for the variation of molar conductance with concentration for weak electrolytes. So here can you calculate lambda naught m value when lambda naught m from this graph? Lambda naught m ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕಾಗುತ್ತಾ ಇದರಿಂದ? No. Why? Because on extrapolating, what happens? This will not cut our y axis. ಏನಾಗೋದಿಲ್ಲ, ಇದು ಈ ಗ್ರಾಫ್ ನಮ್ಮ y axis ನ ಕಟ್ ಮಾಡೋದಿಲ್ಲ. ಬಟ್ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಒಳಗೆ ಏನಾಗ್ತಿತ್ತು? ಗ್ರಾಫ್ ಈ ತರ ಇರ್ತಿತ್ತು. ಇದು ಎಕ್ಸ್ಟ್ರಾಪೋಲೇಷನ್ ಮಾಡಿದ್ರೆ ಏನು ಫಾರ್ಮ್ ಆಗಿದೆ ನಮಗೆ? ಸೊ ದ y axis is cut at this point. So this is nothing but lambda naught m. This is for strong electrolyte. strong electrolyte, and this is for weak electrolyte. Weak electrolyte. So here at infinite dilution, however the dissociation is complete, but also the value of lambda m, the value of molar conductance is very much less. We cannot calculate or we cannot determine it accurately. So because of that reason, for weak electrolytes, the molar conductance at infinite dilution cannot be calculated by graph, but it can be calculated by one more method or one more law, that is called as Colorach's law. So by using Colorach's law, we can calculate lambda naught m value for weak electrolyte, means the molar conductance at infinite dilution for weak electrolytes can be calculated by using Colorach's law. Okay, so about that law we'll discuss in next class. Okay, so thank you. And dear friends, if you find this video is helpful, please like, share, comment, and don't forget to subscribe. Okay, and each and every video of this electrochemistry parts, in the description I have added the link of this entire electrochemistry videos. So go to the description box and click on the link. You are going to get all the videos of electrochemistry. Okay, go and watch. Thank you so much.